Now we have a rough idea as to what is CMSIS. Now here we will see how it is playing a role in our project. So to understand CMSIS, I have opened this web page on ARM's website, and this is the structure that is developed by them or designed by them. Now here you can see the application code, the first layer. This application code is the main code that we write in C. Yeah, so like in this project, this main, this is the main code. This is basically our application code, the code that we write in the main routine, right? So it is the main uh, code that we write in C. You can directly correlate this with the main file of our C project. Now in our code, what we do basically is we write the data in the registers of the microcontroller in order to make an application. So here this last portion is our microcontroller. It contains our Cortex-M CPU core, that is the ALU and all that stuff. It also contains the core peripherals also, like Cortex M4, the controller that we're using. It has many core peripherals like Systic Timer, NVIC, debug, etc. And these other peripheral means our general peripherals like UART, SPIAT, ADC, DAC, etc. So this is our main application code, and this is our microcontroller, and all these blocks between them are different layers of drivers that are available for us to use and develop the application code. So all these blocks in blue, the one written CMSIS on it, are provided to us by ARM. The silicon vendors do not provide them, the ARM themselves provide them, because they are the main standard library of the CMSIS. Now, for example, if the application code wants to directly talk to, say, for this Systic Timer, then you can also write your application code by accessing the raw registers of your microcontroller and skip all these blocks of drivers. It will work. But what is the problem there? So when you change that microcontroller on which you developed this code, you cannot port that code. The address on the other microcontrollers will be different. The bit fields will be different. That means the code you developed here cannot be reused on the different microcontroller. And most of the time what happens is the application developer won't have any idea how to handle some of the peripherals of the processor. In this case it is ARM Cortex M4. So he or she may not be knowing the register structure, he may not be knowing how to turn on or off the Systic Timer, how to enable or disable the interrupt using the NVIC registers, etc. So he or she may not be knowing many things, and all these details the application designer may not be knowing. But that does not stop him from developing an application for Cortex-M microcontrollers. What ARM is saying is that you need not worry about the internal details of the microcontroller. Just use this CMSIS core API that are being provided by ARM. So what this CMSIS core layer does is it provides the application developer with various APIs, and so that the application developer can make use of that and develop whatever applications he wants to develop. So this CMSIS core helps the developer to access some of the core peripherals of the Cortex-M processors. So the benefit of using CMSIS is you need not know all the details of the microcontroller in order to develop an application code. You just need to know some of the APIs provided by CMSIS core. Now there is another reason why we are using this CMSIS core. Now look at this device HAL layer or device hall layer. So this device hall layer is provided to us by the silicon vendors. So the microcontroller that we are using is by ST. So ST will provide us the hall drivers for this microcontroller. So what these silicon vendors do is that they develop their drivers using the CMC core itself. Right. So that is why if you don't provide CMC core layer in your project and use the whole drivers directly, then the compiler will start throwing errors. all the linking and compilation errors will come. So the device fault drivers are developed by silicon vendors such that they will not touch the microcontroller peripherals or core peripherals directly. They will access them via CMC score. So that is the reason you should keep a CMC score in your project. Now, in our project, all these blocks are not considered. What we are using is we are using this CMC score and we are using this device HAL drivers and some of the CMC drivers also. We are not using this middleware layer, right? Now let us correlate all the layers of this block diagram with our actual project that we are going to use. So this is the template that we are going to use, and inside this template all the drivers are available in this drivers folder. So we saw our MCU specific header file which was available inside this device folder, inside this ST. So we saw this in the previous video. Now this device folder contains the MCU specific header files, and this include folder, it contains all the CMC score API. So this is basically the whole CMC score API, and all the Hall drivers are being accessed through all these files. Now our Hall drivers on the other hand are present in this folder, that is STM32F4XX Hall driver. So these drivers are provided to us by ST themselves, right? So these are all the header files of different peripherals of the this microcontroller, and these are all the source files for the same, right? So we are going to use all these source and header files in our project, but for our convenience we have made another layer above the hall, though this it is not mentioned or it is not shown in this block diagram. There is no other layer above this hall, and hall is directly being used using the CMSIS API in the application code. But what we are going to do is we are going to make another layer so that coding is very readable, understandable for the users that are going to use our code, right? So this BSP, it is empty right now, but we will write code using the hall drivers ourselves, and we will create our own BSP drivers, right? So our BSP will basically be using the hall drivers, and it will make the API layer. So basically in the first video of the programming structure, we saw that we are using hall as well as API layer differently. So using this hall, this BSP will contain our main API that we are going to use in our main project, right? So this is basically all our programming structure that you need to understand. And our header and source files will reside in this INC and source folder respectively.